Sample problem. Calculate the concentration in moles per liter of chloride ions in each solution. So what we're going to do is in part A, we're going to start off with 19.8 grams of potassium chloride is dissolved in 100 milliliters of solution. So it's going to dissociate into the following. KCl, right, is going to break apart into potassium ions and chloride ions. So what we've got is 19.8 grams of potassium chloride. So what we want to do is, because we're going to be using stoichiometric methods, from this equation we want to start off with trying to find the number of moles of potassium chloride. To do that, we want to take our mass and we're going to divide it by the molar mass of potassium chloride, which is 74.55 grams per mole. Grams cancel out, and we're left with 0.266 moles. Now, we've got 0.266 moles of potassium chloride, 0.266 moles. Question asked, calculate the concentration of the chloride ions. Concentration is in moles per liter. What we want to do is we want to find the number of moles of our chloride ion, X. So using stoichiometric methods, right? Remember what we were doing? We were trying to find the number of moles and old-fashioned way of molecules. Even though we know about the Avogadro constant, we're treating molecules the old-fashioned way. By using the coefficients that are in front. So, our unknown number of moles that we're trying to find of is for the chloride ion, the Cl negative. Now, what's our given? Our given is potassium chloride, which is 0.266 moles. We are, in this reaction, the ratio is a 1-to-1 ratio. So because it's a 1-to-1 ratio, whatever the moles are for our given is going to equal the moles of our unknown, right? So because it's 1-to-1, the Cl, the number of moles of Cl negative is equivalent to the number of moles of our potassium chloride. So therefore, the N value, okay, of the chloride is equal to 0.266 moles. Now, we're being asked to calculate the concentration. Concentration, the equation for the concentration is C is equal to N over V. So what we're given the N value here, 0.266 moles. We're being asked to find C, right, concentration. We need to find our V, right? And our V should be given, and our V is given. Our V is 100 milliliters. But if you look at the units, right, let me just uncover the units. It's moles per liter. So I must convert 100 milliliters into liters, which is 0.100 liters. Now, for argument's sake, I'm going to convert 100 milliliters into 100.0 milliliters just to avoid the one significant digit rule for my answers, because I hate those type of questions where the answer kind of rounds off to 1. So what we're going to do, and I don't want to go into an explanation of why we don't really use those as the number of significant digits. But anyway, we've got our volume, which is 0.100 liters. Concentration, what we're finding, we've got the number of moles. Right? So to find the concentration, we're going to divide our N value, which is 0.266 moles, and we're going to divide it by our volume, which is 0.100 liters, and the concentration of the following is 2.66 moles per liter. So least number of significant digits are 3. So our answer is going to have 3 significant digits. Remember, I've changed the 100 milliliters into 100.0 milliliters just for some better significant digits. So keep this question, the answer for this one in mind, because we are going to need this, some of the numbers in this question, right, for part C. So let's look at the next sample problem. The next problem, same thing. We're calculating the concentration of the chloride ions in each solution. We have 26.5 grams of calcium chloride dissolved in 150 milliliters of solution. So again, let's make an adjustment to this one. Instead of 150 milliliters, 150.0 milliliters. So our question starts off with 26.5 grams of calcium chloride. So we want to convert our mass into the number of moles. To do that, we're going to take this value and we're going to divide it by its molar mass. And its molar mass is 110.98 grams per mole. So grams cancel out, and I'm left with 0.239 moles. So of calcium chloride, I have 0.239 moles. Right? According to our stoichiometry problems, we're trying to find out the concentration of the chloride ions. So this is what we're trying to find. And with the example before, it was a 1-to-1 ratio. But now it's a 1-to-2 ratio. Right? We look at the coefficients. The coefficient here, there's no number, so it's 1, right? It's a 1-to-2 ratio. So what we do is, so we're revisiting our stoichiometry. We have our unknown, which is the chloride ions, and our known, which is our calcium chloride. So we know how many moles, right? We have moles and molecules. Right? And as I said, molecules, even though we know now the Avogadro constant, we're not going to treat it that way. We're going to treat it the old-fashioned way in terms of molecules. Right? So we've got, we've just calculated 0.239 moles. We're trying to find the number of moles of chloride. We have how many molecules of chloride? 2. How many molecules of calcium chloride? 1. Right? So now, remember, let's just recap the stoichiometry. Right? We separate the two columns with an equal sign. Right? So we have x over 0.239 equals 2 over 1. And what we're trying to find with this x is we're trying to find the number of moles of the chloride ion. So we're left with x is equal to, and all we're doing is shifting the 0.239 over the equal sign. And we're given 2 times 0.239 over 1, which isn't really going to matter. Right? And our answer comes out to 0.478 moles of the Cl negative, right? The chloride ion. So we know the number of moles of the chloride ion. And again, now we want to find the concentration, right? So look at what we're asked. We're asked to find the concentration. It's in moles per liter. We've already found the moles, which means now we need the liters. Do we have the volume?
Yeah.
Yes, so we can use the equation. C is equal to N over V. N, our number of moles that we've just calculated, 0.478 moles, divided by 150.0 milliliters, which is equal to 0.1500 liters, right? We want to keep the same number of significant digits. Right? So if you're converting a number, keep the same number of significant digits. Right? So 0.478 moles divided by 0.1500 liters is equal to 3.19 moles per liter. So that is the concentration of the chloride ions. So we have this answer, we have the other answer. So now let's go about solving sample problem letter C.